Here the diagonals of this quadrilateral ABCD intersect each other at a point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So when can I call ABCD is a trapezium? When two of its sides there are two side bases, right? BC and AD and AB and CD, right? So one of them should be parallel to each other and the other one should not be parallel to each other, right? So then only I can call ABCD as a trapezium. So if I consider my ABCD as like this, okay, so I can either consider it like this or like this, right? Both can be called as trapeziums. So in this case AB is parallel to CD and AD is not parallel to BC, but here AD is parallel to BC and AB is not parallel to CD. Okay, so I'll consider the two cases and I'll see which of them is true. Okay, so if I start here, I'm given that both of them intersect at O. So both diagonals intersect at O. So to show that ABCD is trapezium, I have to show that two of its sides are parallel to each other. For that, what I'll do? Here I'm trying to check whether AB is parallel to CD or not. So I'll construct a line passing through O, which is parallel to CD. Okay. Here I constructed this new line EF. Okay, which is parallel to CD. EF is parallel to CD, and in this case I constructed EF parallel to BC. Okay, so these are two different cases. I'll try not to confuse further. So first I'll check whether AB is parallel to CD or not. Okay, so now if I consider triangle ACD, in triangle ACD, EO is parallel to CD, right? EO is parallel to CD because that is how I constructed this line EF. So then what can I tell? In this triangle ACD, EO is parallel to DC. So a line parallel to one side of the triangle will divide the other two sides in the same ratio, right? So AE by ED is equal to AO by OC, right? Here from this equal to what do I have? I have AO by OC is equal to BO by OD, right? Because here I simply interchanged BO and CO. So then I'll get it like this, right? So if I got it like this, I can substitute this here. So from these two equations, I'll get AE by ED is equal to BO by OD, right? So then what will happen? If I have AE by ED is equal to BO by OD, I'll consider this triangle ABD. Okay. In triangle ABD, even in this triangle, this relation is holding because this is always true. So if AE by ED is equal to BO by OD, then what can I tell? EO is parallel to AB because if I look at this triangle, I see that this ratio of this side to this side is equal to this side to this side. That means that this line should be parallel to this line, right? So in triangle ABD, if this equation holds, then EO is parallel to AB, right? EO is parallel to DC and EO is parallel to AB. This means that AB is parallel to DC. Okay, so these two sides are parallel. Okay, similarly, if I look at the other two sides, okay, here I constructed GH such that GH is parallel to BC. Okay, I have to prove that GH is not parallel to AD for the quadrilateral to become a trapezium, because I already got AB is parallel to CD. So if AD is not parallel to BC, then only I can call ABCD as a trapezium. So for that, what I'll do, in triangle ABC, here I have GO is parallel to BC, right? That is because I constructed GH like that. So GO is parallel to BC. This means that AG by GB is equal to AO by OC, right? And here I also have AO by BO is equal to CO by DO, or I can also write it as AO by OC is equal to BO by OD, right? I can write it like this because I just interchanged BO and CO. So I got AO by OC is equal to this, and AO by OC is also equal to this. So AG by GB is equal to BO by OD, correct? So I got AG by GB is equal to BO by OD. So if I construct this triangle ABD, in triangle ABD, I got that ratio, that means I am constructing this triangle, correct? So in this triangle, I got the ratio of this side to this side is equal to ratio of this side to this side. If it was the reverse, that is, if I would have got AG by GB is equal to DO by OB, then I can say that GO is parallel to AD, right? But here I didn't get that thing. I got some other thing. That means that GO is not parallel to AD. So BC is not parallel to AD, correct? So what do I get? I got that AB is parallel to DC and BC is not parallel to AD. So I can conclude that ABCD is a trapezium.